Today's notes are over graphing the sine and cosine functions on the coordinate plane. These functions are periodic functions. What are periodic functions? They're functions that repeat at regular intervals. The intervals are called cycles, and the length of a cycle is called a period. And we'll get into that further as the notes go on. So periodic functions. I've got the unit circle here, and I want you to imagine I have a point on the circle right here. I'm going to start at this point right here, and I'm going to go all the way around the circle. And then I'm going to keep going all the way around the circle and all the way around the circle. And I'm just going to keep doing that. Okay, so the length of my circle that I'm drawing continues to get longer, but what happens is it hits those same points over and over and over again. So there's a pattern that you will see whenever we're graphing these periodic functions on the coordinate plane, because these sine and cosine functions that we're going to graph, all of the points that we're graphing are straight from this unit circle. So let's move on to the sine parent function. Here's what the sine parent function looks like. And the first thing I want to talk about with this parent function is the domain and range. So the domain is just going to be negative infinity to positive infinity. And then our range goes from our lowest point to our highest point. So as you can see, this lowest point down here, which it does just repeat. Oh my gosh, my line is so bad. That's our low line. And then our highest point up here, which is at +1, that's our high line. And it just goes, there's a pattern, as you can see, from that low line up to that high line. So from -1 to +1, that's as low as it goes and as high as it goes. So our range is from -1 to +1. So our sine function, let's talk a little bit about what you see on this graph. I see some degree measures on this graph, and I'm going to start on my x-axis. And you know what? We're going to call this x-axis, this one in the middle. That's going to be our midline, so put an M there. So on this x-axis, I've got some degree measures. I've got 90, 180, 270, and 360. And if you think about your coordinate plane, or I'm sorry, your unit circle, we're at 0 degrees right here, 90's up here, 180's right here, 270's right here, 360's right there. So if you think about it, one whole revolution around, this circle, the circumference of this circle is 2 pi or 360. That's what we're graphing right here. What I'm going to write underneath that is the radian measures that could also be used when you're graphing trigonometric functions. So 90 is also pi over 2, 180 degrees is pi, 270 is 3 pi over 2, 360 degrees is 2 pi. And we can also go with our negative angle measures. That's negative pi over 2, negative 180 is negative pi, negative 270 is negative 3 pi over 2, and negative 360 is negative 2 pi. So how do we come up with this particular pattern, this sine parent function on our coordinate plane? I want you to notice the pattern. So, and I'm gonna put some points on this graph so you can see how we use the unit circle to create this parent function for this parent sinusoidal function. So the first thing is, recall that the sine value on your unit circle is the y value, right? So all of these y values are our y values on our graph, and our x values are our degree measures. So at 0 degrees, what is y? Y is 0. At 90 degrees, what is y? At 90 degrees, y is 1. That's up here. At 180 degrees, what is the y value? We're back at 0. At 270 degrees, what is y? We're down to -1. And then at 360 degrees, we're back at 0. And because, remember, I drew that circle, right? And I just kept going continuously at the beginning of the lesson, That's why this is all just going to repeat. It is a periodic function, right? And there is the length of one period. What I just drew, this little shape right here, all the way to 360 degrees, is the length of one period, okay? Or one cycle, I'm sorry. So this period is the length of one cycle. So for our sine function, let's just talk about the pattern for this sine function. The pattern, we started our midline right here. We went up to our high line. We went back down to our midline. We went down to our low line. And then we went back to our midline. There's the pattern for the sinusoidal function. And the 360 degrees, that's where we ended right here. That's the length of one cycle, and that's called a period. So the length of one cycle is a period. And let's go ahead and label that up here. So this right here, that's your period. It's the length of one cycle. Now, another thing that I want to point out, is the distance from the midline to the high line. So this distance right here, what is that distance? It's one unit, right? That our midline is at our x-axis, which is 0, or y equals 0, and then our high line is at 1. That is called the amplitude. It's just the distance from your minimum or maximum values and from your midline. So the amplitude. And the amplitude of your sine parent function is just 1. So these are also called wave functions or periodic functions. They're just going to repeat, because just like I did at the beginning of the lesson, right? I'm going to go around. There's one, that's one period, okay? Or that's one cycle. And then I'm just going to go around again. There's another cycle. And there's another cycle. And there's another cycle. And I could just keep going and going and going and going. And that's how I get all of the values. That's how I get that repeated pattern on our graph. So how did we graph this? We graphed our x values were our degree measures. You can graph them in degrees or radians. And then our y values were the coordinates on our unit circle, okay? So just like any other function that we've talked about this year, you can transform these functions. You can, if I put a number out in front, so like y equals 2 sine whatever, that will change the amplitude. That's how high or how low, okay? So that's like our vertical dilation, right? So the amplitude, again, is the distance from your midline to your high line or your midline to your low line. It's exactly the same, but that value out in front will change that. If you have a value after that, right? So like 2 sine 1/2, that number right here is going to change your period, okay? Your period is the length of one cycle. So right now, the period of the parent sine function is 2 pi right here, but your period could change. It could be 4 pi. It could be just pi, okay? And we'll talk about how you graph your points and graph your sine or cosine functions with those various periods. And then inside the parentheses, just like, you might recall from like a quadratic function, if I have something inside those parentheses, right? That's a horizontal translation, okay? It'll move this center line right here, which is our y-axis. It'll move it to the left or to the right, okay? And so even though it might be graphed the same, I'm going to show you how we start with our graph, at those phase shifts, with those phase shifts. So that's another thing that it could be called. It could be called a phase shift. And then plus D, that's your vertical translation. It moves that midline up or down. So let's get into graphing the sine function. In these examples, I've got these two equations right here, y equals a sine b theta minus c plus d. If you see theta, we're going to graph it in degrees. Okay, we're going to use degree measures on our x-axis. If we see an x value in our equation, we're going to use radians. And it's important for you to be able to graph both. As we graph these, we're going to state the amplitude, period, vertical and horizontal translations for each function. Then we'll graph it. In today's lesson, there will be no period changes. So every period will be like one revolution around the circle. Okay, so our period's going to be 2 pi, or 360 degrees, because that's how many degrees are in one circle, or that's how many radians are in one circle. So 2 pi, 360, the period's going to stay the same in every single example today. There will also not be any horizontal translations, so only amplitude changes and vertical translations. In example number 1, you can see that there's a number out in front of sine theta. So the first thing I'm looking at is sine theta. We're going to use degree measures when we're graphing this. Because there's no period changes in today's lesson, what's the period for this particular function? It's going to be 360 degrees. So what we're going to do is we're going to put our center point right here at 0, 0, because that's where our sine function is going to start. And what I'm going to do is I'm going to put 360 degrees right over here. I'm going to put negative 360 degrees right over here. And then I'm going to put 3 lines evenly spaced between each one of these, or as evenly spaced as I can. All right. So, oh, did I do that right? Nope, I sure didn't. I drew 2 and I meant to draw 3. I'm splitting that 360 into fourths. There's 3 lines, 1, 2, 3, and there's 3 lines. So now we need to talk about what are those degree measures going to be. I'm going to take 360 and I'm going to divide it by 4, which 360 divided by 4 is just 90. So we're going to be counting by 90 degrees. So from 0, I go out, there's 90 degrees. Here's 180 degrees. There's 270, and then 360. And then we could go in the negative direction. There's negative 90 degrees, negative 180 degrees, negative 270 degrees, and negative 360 degrees. So now let's talk about how we're going to label our y-axis. Our y-axis, normally, that amplitude is 1. So I'd put a 1 and a negative 1 there. But in this case, our amplitude is 2. How do I know that? There's a 2 out in front of the sign. The amplitude is 2. So I'm going to show you how I might graph this. Because obviously all the graphs are going to look, they're exactly the same. So it's all going to be about how you label your graph. If I say that's 1 and that's 2, now that's negative 1 and that's negative 2. So now it's all about how you label. So in this case, we've got our period at 360, okay? We've got our amplitude at 2. There's no vertical translation and there's no horizontal translation. So now we're just going to graph this sinusoidal function. So recall that the pattern goes mid-high, mid-low, mid, just like that. So we're going to start at 0, 0. At 90 degrees, we're going to go up to 2. At 180 degrees, we're back to the middle. 270 degrees, we're down to 2. 360 degrees, we're at the middle. And it just kind of takes this shape. And it's not going to be perfect. Like, all of my graphs are going to look a little bit different, but I try to graph them as good as I possibly can. And so what I like to do is from that middle line that we start with, I like to go 1 period to the right and 1 period to the left of our midline, or not midline, but of that middle vertical line, okay? So now, because we went up this way, we're going to, at negative 90 degrees, we're going to be down at negative 2. Negative 180, we're going to be back at the midline. Negative 270, we're going to be up to 2. Negative 360, we're going to be at the midline. And it's obviously just taken the same pattern. See, it's obviously not a perfect graph, but that's what this graph is going to look like. Our domain is from negative infinity to positive infinity. So in this case, our range has been changed from now it was -1 to +1 was our parent function, but the range for this graph is now -2 to +2. So a lot of your graphs will look very similar today unless there's like a vertical translation or something like that. But it's all about how you label your X and Y axes, okay? So let's move on to the next one. In this case right here, y equals -sine x plus 2. I'm going to change colors here just because I want to. So in this case, I notice a couple things. There's a negative out in front. Well, what does a negative out in front do to my graph? It reflects it across the x-axis. So what does that mean would happen? That would mean instead of looking like this, it would look something like this, right? So we're just going to start in the opposite direction, if you will. We don't have any other number in front of that sign, which means our amplitude is just the same as our parent function, which is just 1. And remember that that amplitude is the distance from your midline to your high line. So if I go back to number 1, my amplitude is from that midline to that high line right there, which is 2. So if I were to put my dotted lines on here that showed my low line, my middle line, and my high line, you could see the distance from that midline to the high line or the midline to the low line is the same, and it's always positive. It's +2. Going back to number 2, in this case, because there are no period changes, we're not going to have any value right there. Our period is just going to be, in this case, 2 pi. Because I have an x value here, we're going to plot this in radian measure. So let's go ahead and plot our x-axis that will show our period. Okay, I don't have any horizontal changes today or phase shifts. So we're always going to start right there on this y-axis. Now, I'm not graphing that center point at 0, 0 right there because it's not going to start there. I have a vertical translation that I'm going to address in a second. But the first thing I'm going to do is I'm going to plot that period. That period is 2 pi. So again, if there's 2 pi, there's -2 pi. And I'm going to put 3 lines in between. Oh, that's not enough. Let me see. 3 like this. 2, 3. So I'm dividing that 2 pi up into fourths, right? Here's a fourth. Here's a fourth. Here's a fourth, and there's another fourth. Okay, so I only need 3 little tick marks to do that. And I'm going to do the same thing on this side. Okay, so now in our previous one, we took 360 degrees, we divided it into fourths. If I take 2 pi and divide it into fourths, you can do the same thing. I'm going to divide it by 4, and I get pi over 2. So we're going to count by halves. So this is pi over 2, which is also 90 degrees, right? It's the same, we're talking about the same spot, okay? We're just talking in radian measure versus degree measure. So pi over 2, here's pi, and then here's 3 pi over 2, and then 4 pi over 2 is obviously 2 pi. Now I'm going to go on our negative side. I've got -pi over 2, negative pi, -3 pi over 2, and then -4 pi over 2 is -2 pi. So I'm going to erase that so it's a little bit cleaner. And now we're going to talk about, where this is going to start, because in this case, I have a vertical translation. So we're sliding this entire graph up 2 units. This is going to move our entire graph up 2 units. And there's no horizontal translation. So where's my midline now? My midline is not the x-axis anymore. Now I'm going to go up 2, and here's my new midline. There's 1, here's 2, there's 3, right? So that 2 is my new midline, which means this right here is my low line, and this right here is my high line right there. So there's my low line, there's my high line, and there's the midline. So now let's graph this. I'm going to graph it in a different color. We're going to start at what was 0, 0, but now it's going to be 0, 2 because we've shifted the entire graph up 2 units. Now recall, one cycle would look just like that, but since we're reflecting it across the x-axis, we're going to go like this. Oh, not like that. Whoop. We're going to go like this. Okay? So we're actually, instead of going up here, we're going to, at pi over 2, we're down right here at 1. Now, I know, like, how did I get that low line and that high line? Because there's no amplitude change, from that midline, I'm going to go up 1 unit and down 1 unit. Okay, that's how I got that midline and that high line. I just want to clarify that in case I didn't say that. So now at pi, we're back at the midline. At 3 pi over 2, now we're up to the high line. At 2 pi, which completes one cycle, or one period also, we're at back to the midline. So it's going to look just like this. Whoop! And it's really all about how you label your graphs. Just everybody's graph might look a little different because, you know, some kids write really small and some, you know, want bigger graphs. But, you know, as long as you label them correctly, your x and y axes, and plot your points correctly, you're fine. So then at negative pi over 2, we're up at our high line. At negative pi, we're at our midline. Negative 3 pi over 2, we're at our low line. And at negative 2 pi, we're back to the midline. And so it's going to just have the same pattern over here on the left side of that y-axis. So in this case, our range for this function has been changed, and it's no longer -1 to +1 because we shifted it up 2 units and we didn't change our amplitude. Our range is now from 1 to 3. So let's move on, and we're going to graph the cosine parent function. So this looks very, very similar, but it starts at a different place. Okay, that's the best way to describe it. So again, with our sinusoidal function, how did we get all the points on our graph? We used our unit circle, and it was the y values. How do we get all of our points on this function? Well, we look at the x values because those are the cosine values on our unit circle. So I'm not going to go back to that unit circle, but that's where this is all derived. Okay, so when we look at these different degree measures, what's the x value at those degree measures? And that's essentially what we're plotting here. So this cosine parent function, you can see that we still have a midline that's the x-axis. We still have a low line that's -1. We still have a high line that's at +1, which means our amplitude right here is still 1. So the amplitude is the same. It still is, it looks like the same pattern, right? We've got the same pattern. You know, it looks very similar. It's obviously a periodic function. It's going to repeat, you know, it's going to repeat itself over and over and over again, also called a wave function. But notice that the starting point is different, right? The starting point is actually not at 0, 0 like our sine function. It's at 0, 1. Because the x value at 0 degrees is 1. So what's the x value at 0 degrees? Yes, the x value at 0 degrees. So the x coordinate at 0 degrees is 1. The x coordinate at 90 degrees is 0. So we're back here. The x coordinate at 180 degrees is -1. The x coordinate at 270 degrees, we're back to 0. The x coordinate at 360 degrees, we're back to 1. So it takes this little shape right here from that starting point, which is up high. So our pattern for this particular cosinusoidal function is not mid, high, mid, low, mid. It's actually high up here, then mid, then low, then mid, then high. And it's going to repeat itself on the left side of that x-axis as well. Now again, just like we did with the sinusoidal function, for this function, this cosinusoidal function, we can also plot this in radian measures. So 90 degrees is also pi over 2, 180 is pi, 270 is 3 pi over 2, 360 is 2 pi. And we've got our negative degree and radian measures on this side of our y-axis. So negative 3 pi over 2, and then we're at negative 2 pi. So you can label those the same. And as you can see, the period is the same, right? It is the length of one cycle. One cycle is just like, picture if I were drawing my circumference around that circle, right? That's one cycle, okay? Once it starts repeating itself, that's another cycle, right? Then another cycle, then another cycle. So it's the length of one cycle, which is 360 degrees or 2 pi. And again, just like we just did, and I'm going to draw this little guy right there, right? So that's like your cosinusoidal function, okay? Just like we did with our sine functions, we can transform our cosine functions in the same manner. So if I have a value out in front, that changes our amplitude, how high or low, or how high or low. The b value, which is after like the cos or the sine, which we're not going to have today, that changes the period. It'll squish it or stretch it. We can have a horizontal translation inside the parentheses, which we don't have today. We also call that a phase shift. And then we can have a value out to the right of all of that, which will show a vertical translation, or it's a constant that's been added or subtracted to our function. And that will move our entire function up or down altogether. Just like we did with our sine functions, if we're using theta, we're going to graph in degrees. If we're using x, we're going to graph in radians. And that's typically what you see. But you'll see some people, graph with both. So on this last, I think this is the last example. Yeah, this is the last example for today. It says to state the amplitude, period, vertical and horizontal translation for the function, then graph. So we have a cosine function here. That's the first thing that I notice. And what I like to do, especially when I'm starting out doing this, I find it very helpful for students to go to say cosine. Okay, we're starting like that. Okay, if they have a sine function, they might draw something like this. And that just helps with how to think about it first, because this is a lot of information, a lot of new information for students. So moving along, let's go ahead, and the first thing I want to point out is this 1/2 out in front. What does that 1/2 do? It changes the amplitude. Remember, it's that distance from your midline to your high line or your midline to your low line. It's always positive, and instead of being 1, like your parent function, it's now 1/2. Your period, because we're not changing any of that today, and we're having an x value here, our period is 2 pi. Okay, that's one cycle around your circle. We do have a +1, which what does that do? That's going to move our entire graph up 1 unit. And we don't have a horizontal translation here. So now let's graph. I like to graph the midline first. So if we're moving up to 1, there's our midline. There's 1. Okay? And you don't have to draw these lines here. I'm going to go ahead and draw our midline. Some graphs I don't draw any dotted lines. Some graphs I draw a lot. Sometimes, it changes. So now because our amplitude is 1/2, that means this right here is going to be 1/2. There's 1, and there's 1.5. And I like to write 1.5 as an improper fraction, which is 3 over 2. And those are here's our low line. And then here's our high line. And I don't know if I've drawn all of these dotted lines on any other example on today, but I'm going to for this one. So now let's graph, let's plot the other measures, or the measures on our x-axis. And if you want, you can do your graph down below your x-axis, but we're not really worried about that, so I don't care if you graph that or not. 1 period is 2 pi. So out here, I'm going to put 2 pi, and out here, I'm going to put negative 2 pi. And how many points or little tick marks or lines do I draw in between? 3. 1, 2, 3. 1, 2, 3. We're splitting that period up into fourths. So 2 pi divided by 4, that's pi over 2. We're counting by halves. That means this tick mark is pi over 2. This is 2 pi over 2, which is pi. This is 3 pi over 2, and then there's 4 pi over 2, which is 2 pi. And then I'm going to have the same thing on this side of my y-axis, but they're all negative values. Okay? And now let's graph. So the points on this particular graph, recall that your cosine function will start at the high point. So if this is my midline at 0 degrees, my high point is going to be up here at 3 over 2. Moving to pi over 2, I'm going to be at the midline. At pi, I'm going to be down to the low line. 3 pi over 2, I'm going to be back to the midline. And at 2 pi, I'm going to be up at the high line. And it's going to look just like this. And there's one cycle. And the length of that cycle is 2 pi. So now let's graph another cycle to the left of our center line, of our center vertical line. So we're up at the high point. We're going to go down to the midline, then down to the low line, then up to the midline, then up to the high line. So the really important part is going to be labeling your x and y axes together, okay? And now in this particular problem, our range is now, the parent function was from -1 to +1, which, you know what, I don't think I wrote that down, which we'll do that. I'll make sure I cover that at the end of this problem. So the range for this particular problem is from 1/2, that's our lowest point, up to 3 over 2, or 1.5, 1.5, however you want to write it, is our range. So let's go back to our parent function. I want to make sure that you have this in your notes. The domain for the cosine parent function is -∞ to +∞, and your range is the same as the sine function, which is from -1 to +1. And that concludes your day 1 notes over graphing sine and cosine functions with amplitude changes and vertical translations. I hope it was helpful.